Hi everybody. We're going to have a quick look at comparing fractions, and sometimes it's difficult to tell which fraction is bigger. A fraction wall is often a good help when we start out. So if we're wanting to know is 2/3 bigger than a half, we can use an area model. If we look at 2/3, here's a third, here's another third, that would be this big. And if we look at a half, it's this big. Obviously the 2/3 is bigger than the half. Easy done. But we won't always have a fraction wall, and if we look at this next example, it's got sevenths in it, and my fraction wall doesn't have sevenths for some strange reason, so we better look at a different way of doing it. And there are two easy ways to compare fractions. One is to create equivalent fractions, and then compare the numerators, and we typically do that in the non-calculated section of a test, or if we didn't have a calculator. And the second way is to convert the fraction to decimals, and by dividing the numerators by the denominators, and then comparing the decimals. So let's look at both types. Let's solve 2/3 is 2/3 bigger than a half using equivalent fractions. So we'd write down the two fractions and we'd look for a common multiple. So let's list the multiples over here. I've obviously skipped a few steps. So 3 would be 3, 6, 9, 12, so on and so forth. 2 would be 2, 4, 6, 8, and so forth. And if we had a look, 6 exists in both lists. 6 is the common multiple. That's the one we're going to try and make. So starting with 2/3, how do we make sixths from thirds? Well, we need to multiply the denominator by 2, that would give me sixths. And if I'm going to do that and not change the proportion, I'll need to multiply by 2 on 2. So 2 times 2 will give me 4, 3 times 2 will give me 6. And thus 2/3 is in the same proportion as 4/6. And let's have a look over here. 2/3 is in the same proportion as 4/6. We have a shape which we have thirds, 1/3, 2/3, 3/3, and 2/3 are shaded. Then we make it into sixths by splitting each of the thirds in half, and we can see that 4/6 is shaded. Nicely done. And we can do the same with halves. To get halves into sixths, we're going to multiply by 3 on 3. 2 times 3 will give me 6, that gives me my sixths. 1 times 3 gives me 3, that preserves my proportion. Let's have a look and see what that would look like pictorially. Here's a half, one half of the shape. The other half of the shape, one half is shaded. I'm going to split this half of the shape into thirds, and then I'm going to count the parts, 1, 2, 3. So I started with halves, I went to sixths, I divided this into 2 more parts. In fact, I might just do that. That way we can see the sixth in both shapes. Oops, that's pretty ugly. Let's try again. There we go. So we can now see sixths in both shapes. And you can see here that there's 3/6 over here. So we can do it pictorially, we can do it with arithmetic. And now we can compare. Well, from the two shapes, we can see that 2/3 is obviously bigger than a half because we shade a higher proportion of the shape. We shade 2/3 of it as opposed to half. More area here, less area here. But we can also see from our equivalent fraction that the numerator is bigger than the numerator for 2/3 is bigger than the numerator for 3/6. Start again. The numerator for 4/6 is bigger than the numerator from 3/6. Therefore, 2/3 is bigger than a half. Over here, we've got the greater than symbol. Now, students would have been taught about crocodiles and all sorts of ways to remember which one's greater than and which one's less than. The easiest way I know is to say that less than looks like an L, therefore greater than is the other one. And unless the student is dyslexic and looks at L's backwards, they're not going to get that wrong. Another little symbol that you might want to learn is this dot 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 thing. Dot dot dot. We say that that's just a mathematical way of saying therefore. So here I'm saying therefore 2/3 is bigger than half. Alright, well let's look at 3/7 and 2/5 now, the one we couldn't do before. Over here I've written that LCM, the lowest common multiple, is 35. Let's just check that because I've just said it, but I haven't shown it. So 5, 10, 15, 20, 25, 30, 7, 14, 21, 28, 35, probably another one over here, 35, and you can see that the lowest common multiple, the first number that exists in both lists, is 35. So we're going to try and make denominators of 35 so we can compare the numerators. So to get 7 to 35, we're going to multiply by 5. 7 5s are 35. If we multiply the denominator by 35, we need to multiply the numerator by 35 too. 3 times 5 gives me 15. The equivalent fraction of 3/7 is 15 over 35. Do the same thing for 2/5. 5 times 7 is 35. If we multiply the numerator by 7, we have to multiply it. If we multiply the denominator by 7, we have to multiply the numerator by 7. 7 5s gives me 35, 2 7s gives me 14. 14 over 35 is equivalent to 2/5. Which one is bigger, 2/5 or 3/7? Well, it's going to be 3/7 because 15 over 35 is bigger than 14 over 35. Thus, we get this answer here. So, equivalent fractions all of a sudden becoming useful, and we'll use them again when we're doing addition soon. But what if we don't want to use equivalent fractions and we have a calculator? Well, this is a little bit easier. We take the numerator, we press divide, we take the denominator, we press equals, and it would give us 0.5, and that's what I've said over here. 1, press the division symbol, 2 equals, would give us 0.5. And similarly, 2 divided by 3 would equal 0.666666. I should probably make that 67 just to round it correctly. Comparing these two, 0.6667 is bigger than 0.5, therefore 2/3 is bigger than a half. Similarly for 2/5 and 3/7. 2/5, if we go 2 divided by 5 on our calculator, will give us 0.4. 3/7, if we go 3 divided by 7 on our calculator, will give us 0.429. We would think about, all right, well, they've both got 0.4. We need to go to the next digit. They go to 0.40 and 0.42. 0.42 is bigger than 40. Therefore, we know that 3/7 is going to be bigger than 2/5. And that's how we can find whether a fraction is bigger than another fraction, how we can compare them. I hope that was helpful, and we'll do some more exercises on this in class, I imagine. Thank you, everyone.